and then you add it by c because it's an indefinite integral. That's how you solve that problem. We're around halfway there now. So number 5 asks us to solve 1 over x to the third plus 4x. Which, partial fractions doesn't look like it's going to work. U substitution doesn't look like it's going to work. So one of the only options left is to try partial fractions, but it gets a bit tricky. With the denominator, one thing you could do is factor out the x, which would leave you x times x squared plus 4. Now you might think that this won't leave you to do anything because you have an x squared here instead of an x. But because there's a degree here that's greater than 1, remember that the alternative version of the partial fractions formula, where this actually turns into a over x as normal, and then this is where you would use bx plus c over x squared plus 4. Why? It's irreducible. You could not factor this even if you tried. So that's the numerator you use when there's a irreducible denominator. So now we got to figure out whatever values of the a, b, and c we could figure out. Before we do that, we got to multiply both sides of this by this denominator, which will give us 1 is equal to a times x squared plus 4 plus x times bx plus c. So what we could actually do is if we make x 0, that will still be left with we'll still be left with a value for a. So then we'll actually get a times 4, and then nothing else because x multiplied into everything else is just 0. Which will turn into 1/4 is equal to a. So now we know our a value, but there's no clear way of getting our b or c value. But we can work around this using some algebra. So if we actually expand this a little bit, so multiply the a into the radical, and then multiply the x into the, not radical, parentheses. Then you group like terms again. You'll notice that we already know the value of a, so this a could just turn into 1/4. Then this cancels out, leaving us with just 1. And then subtract 1 from both sides. We get 0. Now, with algebra, both of these terms are going to be set equal to 0. So 0 is equal to x squared. Actually, 0 is just going to be a plus b, and 0 is also going to be c. We know the value of a, again, so that's just 1/4. So we could actually figure out that b is equal to negative 1/4. But 0 is c, so there's nothing you can really do about that. So how you would treat this irreducible numerator here and this numerator here is that we plug this figure, we plug these terms back in our integral. So we know now that a is equal to 1/4, so 1/4 times x plus c is nothing, so we just don't write anything. B is 1/4, but there's an x next to it, so we would actually just put the x up there over 4, and then this should be subtraction. 4 times x squared plus 4, because that's our denominator here, but we're just including the negative 1/4 that we found for the value b dx. Now we could separate these terms, because it's subtraction, not division or multiplication. We could take the 1/4 out of both sides. This will turn into 1/4 ln of x without any further calculation there. But this is a little tricky. This does not go into a tangent identity because this is a 4 and not a 1. There's no way to factor this. So the only thing that's left to do is a u substitution, even though you have a squared exponent there. U is equal to x squared plus 4. du is equal to 2x dx. And then dividing both sides by 2, you get 1/2 du x dx. X dx turns into 1/2 du. Just write it over here to make things simpler. And then this denominator turns into u. This 1/2 is a constant, so it's taken out and multiplied by 1/4, which gives you 1/8. Now this becomes minus 1/8 ln of u. And now we got to combine these two to create 1/4 ln of x minus 1/8 ln of x squared plus 4 plus c, because this is an indefinite integral. Next problem we have